Hello everyone and welcome to today's webinar, Plant Growth Regulators, Profoundly Powerful Tools for Horticulture Production. I'm Kate Spurgeon, editor of Greenhouse Management Magazine, and I'm so glad that you could join us today. Today we have Dr. Joseph Rexco, Technology Manager at Mycorrhizal Applications, who will be telling us all about PGRs and how these essential compounds impact plant growth and development. So he'll be telling us about how you can use these naturally occurring or synthetic substances in your own professional operations in a sustainable manner, review many of the frequently asked questions and concerns regarding this technology, and discuss how you can adjust growing protocols to take full advantage of the PGR benefits. He's also going to cover the scientific basics of PGRs and how the use of these substances leads to improved plant quality and ultimately an improved finished product. So before we get started, just a couple of housekeeping notes. We're going to have lots of time at the end for questions. So throughout the presentation, if you have a question, please go ahead and enter that into the Q&A box at the bottom of your screen, and we'll get to as many of those as we can at the end of the presentation. Also, please note that a recording of this webinar will be available in a couple of days, so anyone who registered will receive a link to the recording via email. So with that, let's go ahead and get started. Welcome, Joseph.
Thank you. Welcome, everyone. Thank you for joining this technical webinar today about plant growth regulators and their use in horticulture, focusing on ornamentals. And today I'm going to talk first about plant hormones and the difference between plant hormones and plant growth regulators. Then I will expand a little more on plant growth regulators and spend some time explaining the uses, the benefits, the different types of these products, and what factors influence their efficacy and how they can help nurseries and greenhouse growers, for instance. And in the second half of this webinar, I will talk about the technical aspects of some of the valent biosciences and mycorrhizal applications, PGR products for ornamental use. So then let's get started. First, let's see what plant hormones are and what plant growth regulators are. So well, we know that these terms are often used interchangeably, and both influence physiological processes, plant growth hormones and plant growth regulators in plants, and they are effective in very small quantities. But there's one important difference between them, and it is their origin. So while all plant hormones are naturally occurring, plant growth regulators can be either naturally occurring or synthesized. So these are the main differences between these two types of chemicals, the plant hormones and plant growth regulators. The plant growth regulators could be not just naturally occurring, but chemically synthesized. And traditionally, there are 5 major plant hormone groups: the auxins, cytokinins, gibberellins, abscisic acid, and ethylene. And I'm going to talk a little bit about it, about these plant hormones in a little bit. And let's focus on PGRs. So what do they do? In fact, they alter the plant growth and the development in several ornamental plants. And this could include increased branching or increased plant compactness. They can increase or reduce plant height. It depends on the desired effect. For instance, it is desired to increase the plant height or the elongation of the stems or the flower stems for cut flowers. However, the reduction of plant height might be more desirable for potted flowers. They also improve flower characteristics and flower numbers or flower size could be impacted by plant growth regulators, and they can remove flowers from stock plants. That is important for nursery production, for instance. They can delay senescence, increase vase life of cut flowers. They can break dormancy or improve seed germination. So as you can see that they play an important role in many different processes, developmental processes of the plants that could be useful for commercial ornamental production. And when we use plant growth regulators, we normally enhance the quality of the crop and add value. So that in fact differentiates plant growth regulators from other production inputs like plant production inputs like insecticides or fungicides. When applying an insecticide or any pesticide, you try to protect the crop. So try to keep the quality of the crop. It doesn't necessarily enhance the quality of the crop. However, when you apply plant growth regulators, it is important that we can in fact increase the quality by increasing the number of flowers, increasing the size of the flowers on an ornamental plant, or increase the vase life of cut flowers. So there are many different uses that in fact enhance the crop quality and in fact add value to the grower. And another important thing that I have to mention here is that PGRs are normally applied for specific purposes. So when we are talking about other crop inputs, for instance, biostimulants, they are used for general purposes, for instance, increase general plant health of the plant, but not for very specific uses. However, in PGRs, we are normally very, very specific what we want to achieve. It could be increased branching. Again, it could be increased flower number. It could be reduced plant height. So we always achieve very specific purposes when applying plant growth regulators. And let's look at the benefits, what the benefits are from commercial standpoint. So we just talked about the increased value of the crop, and they can also, when PGRs applied, plants can reach marketability in a shorter period of time. So that helps nursery growers, for instance, increasing the number of production cycles in a year. They can substitute for more expensive growing practices, pruning and shearing, for instance. So when we talk about increased branching, for instance, with cytokinins, they increase branching, and in fact, they can substitute for mechanical pruning or manual labor for shearing. So these are more expensive growing practices that could be achieved just by an application or a couple of applications of plant growth regulators. They keep the quality of the crop longer. This is important for extending the vase life of cut flowers, for instance. And also management of environmental conditions could be mentioned here when we talk about photoperiod or temperature that is required for instance, dormancy. In particular plants, say in azaleas, for instance, it is required, chilling is required for flower formation, flower initiation. And this could be counteracted, or this could be completely or partially substituted with gibberellic acid applications, for instance. So there are many different uses and many different benefits of plant growth regulators in ornamental production. And now let's look at the classes or the groups of plant growth regulators. And according to the American Society of Horticultural Sciences, there are 5 different classes or 5 different groups of plant growth regulators. And these are auxins, gibberellins, cytokinins, growth inhibitors, and growth retardants. And if you recall, just a couple of slides ago, we talked about the main classes or groups of plant hormones, and those were auxins, gibberellins, cytokinins, abscisic acid, and ethylene. And in this particular case, when we talk about plant growth regulators, abscisic acid and ethylene are grouped into growth inhibitors, or they are called growth inhibitors. And there's a new category in here in the plant growth regulators, and these are called growth retardants. And these are normally synthetic compounds that reduce shoot growth. So if we just quickly go through these one by one, there are very specific uses, very specific practical uses of these plant growth regulators. Auxins, for instance, NAA or naphthalene acetic acid can increase the cell size. It maintains apical dominance. Apical dominance is important because it prevents branching, for instance. It also increases rooting, and most of the rooting hormone products contain auxins that are commercially available. Gibberellin is also responsible for cell enlargement, flower induction, flower reduction. They can help breaking dormancy or substituting temperature or cold or chilling requirement for flower initiation. They can increase seed germination, breaking dormancy, delay senescence. And one important thing that I can mention here is the modification of sex expression of flowers. For instance, in cucumber or watermelon plants, when they are sprayed with gibberellic acid, the ratio of male and female flowers change significantly. So when gibberellic acid is applied, there are more male flowers and less female flowers produced on these plants. There are cytokinins, and 6-benzyladenine or 6-PA is a great example for cytokinins, and cytokinins increase cell division, so they increase the number of cells, and this is how they increase the growth of the plants. They counteract apical dominance, and this is in fact the opposite of what auxins do. So when cytokinins are applied, they increase the branching, and they can also delay senescence. The growth inhibitors like abscisic acid or ethaphone are good examples here. They promote leaf and fruit abscission, they regulate dormancy. Also, stomata opening is controlled by abscisic acid, and they can also delay seed germination. And there are growth retardants and uniconazole, diminozide, or prohexadiene calcium. These are all synthetic gibberellic acid biosynthesis inhibitors, and they simply reduce shoot growth. So they just do the opposite as cytokinins or gibberellins do in this particular case. And let's quickly go through the critical factors that affect PGR efficacy. So I listed a few factors here that I believe probably the most common or most important that we have to review before application of plant growth regulators. And the rate or dose is very critical, as the definition mentions only small or very tiny amounts when required. And this is why when we talk about PGRs or plant growth regulator applications, we express the concentration or the rate as ppm. This is parts per million, which corresponds to 1 milligram of active ingredient in 1 liter of water or 1 liter of spray solution. And when we talk about rates, obviously the rates could be too high or too low, and when it's too high, there are potentially undesirable effects. So when we apply too much of a product or of a gibberellin, for instance, that increases the elongation of the stems, and we over apply, we just got an extremely long stem that is undesirable, and in some cases it could cause phytotoxicity as well. Too low is normally potentially insufficient, so we just don't get the required effect that we would like. The timing, it is also very important, because at different physiological stages of the plant responds differently to these plant growth regulators. If the application is too early, the plant might be immature and not ready for the treatment. If the application is too late, the responsive stage has passed, and maybe we get a different effect. So if we just want to bring up an example with azalea, for instance, in the flower development stage, a high rate of gibberellic acid, for instance, substitute for the chilling requirement to help break dormancy and advance flower development. However, if the same gibberellic acid is applied at in the vegetative stage, it in fact reduces flower formation or inhibits flower formation. So the timing is very important. Also, the environment plays a very crucial role in the uptake and the plant responsiveness of the plant growth regulators. And obviously temperature, humidity, water status, light, and other factors could be mentioned here. And plant growth regulators are normally applied as spray solutions. However, obviously there are drench or other applications. But when plant growth regulators are sprayed, the spray applications are normally recommended to be put on either early in the morning or late in the evening when the temperature is a little bit lower and higher humidity can help the absorption. So they won't dry up very quickly, very fast from the leaf surface. And there's an extended period of time while the plant could take up these chemicals. Also, cultivars. Since in ornamentals, cultivars play an important role, it is important that cultivars can play a critical role in PGR efficacy, because what happens is, for instance, in hosta, plantain lily cultivar, 6-PA or cytokinins are applied at a very wide range. It could be applied from 500 ppm to 4,000 ppm rates, and the rate is highly dependent on the cultivar. So it is very important that we know what cultivar we are working with and how they respond to the plant growth regulators. And if something is unknown, there's a new cultivar in the operation, and we don't know too much about the efficacy, it is best just to try the effect of the PGRs on a few plants and see how they respond before applying it to a large number of plants. The application method also impacts the efficacy. Could be applied, PGRs normally applied foliarly, however, they could be applied as a drip or drench or even a seed treatment. And also the volume of the spray or the drench impacts the efficacy, and also the application of adjuvants or surfactant that can increase the uptake. So these are the main factors that affect the efficacy of PGRs. And now let's talk a little bit about products. And before doing so, I think I have to explain the relationship between Valent Biosciences and mycorrhizal applications, because we often get the question, so why are we talking about BBC or Valent Biosciences and mycorrhizal applications, and how do we come together? So what happens is mycorrhizal applications is a wholly owned subsidiary of Valent Biosciences, and mycorrhizal applications is the North American outlet for the turf and ornamental industry for plant growth regulators. And the current portfolio includes a cytokinin product that is called CytoFlor, and gibberellic acid product, and this is a ProGibb LV plus TNO. And in 2021, early next year, we expect the registration of a new product. This is an abscisic acid product, and it is cone shape. And I'm going to talk about these three main products in a little bit in the second half of this presentation, and I'm going to give you a little more information about these. And of course, in the future, there are more products coming for the TNO industry. There are exciting products in the pipeline. And here's a little bit of history of the PGR product development activities of Valent Biosciences, and in fact, everything, including the PGR research and product development, started in 1960s as Abbott Laboratories in the northern suburb of Chicago, and a couple of years later, the first gibberellic acid product was released and registered for agriculture use. And since then, there have been more products come into the market, and mostly for the horticulture and mostly for the fruit industry, and they contain gibberellic acid, cytokinins, benzyladenine, and retaine is a product with the active ingredient of AVG. It's amino ethoxy vinyl glycine. It is a ethylene biosynthesis inhibitor. Then in 2000, what happened is a company called Sumitomo Chemical, company with the headquarters in Tokyo in Japan, acquired Abbott Laboratories, and Abbott Laboratories became Valent Biosciences. So Abbott Laboratories was renamed and became Valent Biosciences, and there are more products. There were more products in the pipeline, and the first, for instance, the first 6BA product for or first cytokinin product for fruit production, pure cytokinin product for fruit production, was launched in 2003, and in 2009, the first abscisic acid product was registered in the US and around the world. In 2014, the world's largest manufacturing facility was built for plant growth regulator production for fermentation, because most of the plant growth regulators are produced through fermentation. And this facility was built in Osage, Iowa. And in 2018, only a couple of years ago, the Biorational Research Center dedicated to biorational research, including plant growth regulator research and also product development, was established. And to talk a little bit about ornamentals as well, in 2020, earlier this year, Cytoflor received registration, which is a commercial cytokinin product for ornamental use, and early next year we expect registration for the abscisic acid product for Christmas tree leader control. And now let's talk a little bit about these products, and let's look at the technical aspects of these products, how they could be applied, what their benefits are, and a couple of slides about on the results as well. So first, Cytoflor, which is a cytokinin product, and the active ingredient is 6-benzyladenine or 6-PA. It's a water-soluble liquid with 1.9% active ingredient content, and the package size is a quart, biorational compliant, and it could be used in the greenhouse, in nursery operations to promote branching, flower development, and also remove undesired fruit. But I'm going to go into these details in the next slide or so. The use rates are normally from 100 to 3,000 ppm, and the coverage is very important because this product doesn't move readily in the plant. So it is important that the desired plant part receive the application, the spray application. It's a proprietary formulation, very user-friendly, and it has an excellent plant uptake. And when we talk about the uses, I have to mention the Christmas cactus use. It is a very old use of for cytokinins. Cytokinins promote both flower development and phylloclade growth, or the vegetative growth, depending on what stage the plants are, and the rates are normally 100 to 200 ppm. Plantain lily or hosta is also an important use for cytokinins and for cytoflora in particular. And as I mentioned earlier, variety or cultivar or plays a major role here, because from 1,000 to 3,000 ppm application rates, different cultivars respond differently. Annual flowering ornamentals, perennial flowering ornamentals, and also the tropicals can be grouped together for both branching use and also increased flowering or flower formation uses. And there are two uses that I'd like to elaborate on a little more, and this is the general ornamental use and ornamental apple and pear use. So the general ornamental use is probably the most important for cytokinin based plant growth regulators to improve branching and improve flower formation. And the ornamental apple and pear use is a new use that has never been registered for the ornamental industry. And I'm going to talk about these just right here. So when we talk about general ornamentals and increased branching and flowering, we can say that increased lateral branching and foliage density in a wide variety of annual perennial plants is promoted by cytoflora, and so this results in a more compact plant, and this is important for many different ornamentals, potted plants. Just one example for that. And sufficient growth of the plant is required to allow for sites of lateral development. So it is important to spray the plants at a stage when they are ready for branching. They are ready for this type of growth, because if we apply too early, there's just not enough side. There's just not enough axillary buds that would be able to break and form branches. And this product and cytoflora increases flower bud formation. The rate is normally ranges from 50 to 500 ppm. The most common rates are somewhere between 200 and 400 ppm. And multiple applications are allowed for greater efficacy. If one application is not enough, or the sufficient effect or desired effect is not achieved, it is better to wait 7 to 10 days to see the effect and then reapply it again to get a better response. The product doesn't move readily in the plant, and complete coverage is required, that I just mentioned earlier. And here are a few photos from our internal trials where we applied this product for branching and also increased flower formation. So in SEMPERVIVUM, for instance, on the left hand side, you can see the untreated control, and on the right hand side, the plant after the application of cytoflora, only 250 ppm 6-PA concentration, caused significant increase of chick formation in this particular plant. And this is important not just for aesthetic reasons, but I would say in nursery operations or in propagation stage, that just a huge number of offsprings that you can achieve with the application of cytoflora in this particular plant. In boxwood, it obviously can increase the branching, the lateral branching of the plant, that results in a better looking plant that is of higher value. So in this particular case, on the left hand side is the untreated control, on the right hand side a plant after 500 ppm application of 6-PA or cytoflora. So there's just a huge difference. It obviously increases the value the crop and increases the quality of the crop. Here's a DAPHNE in a study that we conducted in DAPHNE. And what I'd like you to focus on is the buds in both the untreated and the cytoflora treated plants. You can see that in the cytoflora treated plants on the right-hand side, all the buds broke. So that that results in a more compact plant and a better looking plant with denser canopy that is more desirable for the customers. And here is a lavender plant from our experiment where we were able to increase the pot filling or the appearance or I would say the density of the foliage of lavender, which obviously increases the value of this plant. So with these examples are just a few that we can mention, how useful a cytokinin product could be by increasing the branching or the flowers or the flowering or flower numbers on a plant. And this is the use that I'd like to talk to you about a little bit. And this is the ornamental apple and pear use where cytokinins could be used to remove undesired fruit. So obviously the main aesthetic value of these flowering apple and flowering pear trees is the flower. And cytoflora aids in the removal of undesired fruit from the tree after flowering. So later on, as you can see on the bottom photo, there are fruit remaining on the tree, and these fruit are normally undesirable, and they can rot later in the season, and it's better to remove these fruit right after flowering. So the mode of action is very similar as to the fruit thinning chemicals with the same active ingredient in commercial apple orchards. For instance, Maxell is another product that is used in the fruit industry to remove apple and pear fruit in commercial apple orchards. So, and this is another beneficial use for cytokinins. The application time is normally 2 weeks after flowering. And another thing that I like to mention here is that plant hormones produced by the seeds of these fruit, of these ornamental apple and pear fruit itself, inhibit the flower formation. So the more fruit we leave on the trees, the more inhibitory effect is done to flower formation. So what cytoflora does, in fact, by removing these fruit or right after the flowering stage, these fruitlets, they actually increases the potential of flowering or a better flower density in the following year. So it just secures a better looking tree and with more flowers in the following year. And let's talk about the gibberellin product. This is ProGibb LV Plus TNO, turf and ornamental use. And this product contains gibberellic acid 3. This is one type of the many gibberellins that is active in plants. And the formulation is a water-soluble liquid, and this is a new formulation. And earlier we had a ProGibb, an older version of this formulation that had only half of the ingredients. Now the ingredient concentration is higher, it's 5.7%, and it is a low VOC product, which means low volatile organic compounds and not flammable. So it's easy from transportation purposes, and it is listed for unlisted for organic uses. And it could be used in ornamental crops, many ornamental crops, cut flowers and turf grass, at a rate ranging from 1 ppm to 2000 ppm. And it is a proprietary formulation, user-friendly, and there's an excellent plant uptake. And I'm just going to show you a few plants that this product has been registered for. Bedding plants, potted plants, bulb ornamentals, also free field-grown ornamentals, cut flowers, and besides these, turfgrass applications are also listed on the label. And I'm not gonna go through all of these, but I just want to mention the main purpose or the main uses of this gibberellic acid product. And being a gibberellin, it could replace chilling requirements in azalea or camellia, for instance. It could be a partial replacement with a lower rates, or a complete replacement with a higher rates, like 1000 ppm, for instance. It can break dormancy in hydrangea, for instance. In many different flowers, it increases the flower number, or it could increase the flower size as well. And in cyclamen, it helps achieving a more uniform flowering. And in many plants, it promotes plant growth as well. It promotes stem elongation, and it is very important for cut flowers such as aster, delphinium, and sunflower, for instance. And another thing is to overcome the applications of growth retardants. So in field-grown ornamentals, for instance, there's a high number, or it's a high number of applications of growth retardants, gibberellin biosynthesis inhibitors, and if they are accidentally over-applied, gibberellic acid or ProGibb LV Plus can help overcoming or reversing these effects. And they also maintain the growth and the leaf color in turf grasses, in Bermuda grass specifically, and in stressful periods like during the summer, and the heat is very high, and under drought conditions, and also in the winter they lose their color. So it maintains the growth and the nice lush green color of these grasses. And so these are just a couple of photos from experiments, and so different rates results in different growth responses. So the higher the rates, the greater growth response could be expected. In this particular case, from 0 ppm to 200 ppm, there are huge differences, and there's a very strong rate response in case of gibberellic acid. This is the use that I just mentioned briefly, and that was the PGR antidote effect to overcome the over-applications of gibberellin inhibiting plant growth regulators. Paclobutrazole, uniconazole, for instance, reduce the growth of the plants, and if they are over-applied, they could be easily overcome by the application of ProGibb. And here is a turfgrass study. So on the left-hand side is the untreated control, and on the right-hand side, we can see the ProGibb application. So it is very visible how gibberellic acid can increase the color and also the growth, the activity of the plants in this particular case. So that was briefly about gibberellic acid. And last but not least, let's talk about an abscisic acid product, which is a new active ingredient for the ornamental industry or the Christmas tree industry. And so this is a product that is used to reduce growth of Christmas tree leaders, because what happens is Christmas trees are grown for many years, 7-8 years in the field before they reach their maturity or their mature stage for sale. And every single year they grow their leader much more than it is desired. And to control, and this requires obviously manual labor to pinch them or to shear them back, but this product could be used to reduce the growth rate of the leaders. And this particular product is a water-soluble liquid product containing 10% abscisic acid, or SABA, and it's a biorational compliant, and hopefully it's going to receive organic approval once it's registered for use in the US. And the use rates range from 11 to 45 ounces per gallon, and this is a proprietary formulation with an excellent plant uptake. And just to briefly mention the Christmas tree situation or use here is that, so on the photo you can see that this is a desirable Christmas tree shape, and the shape and the density of the canopy determine the price of the Christmas tree. So it's very important to have a very nicely branched and very nice shaped Christmas tree. And what cone shape does, it reduces the leader growth of the plants of these trees, and the same number of buds on a shorter leader means denser and more characteristic Christmas tree shape. So what happens is that the buds for the following year that become branches or are already formed, and they are present on the leader, and if they are cut back manually, part of those buds are removed via cutting. And what cone shape or abscisic acid does, it naturally shortens the leader or the top of the tree, but it retains the same number of buds. So the trees in the following year can branch nicely, and they could have a better and a denser canopy. The average leader growth is normally 30-40 inches annually, and the desired length is only 12 to 14 inches. So, and this could be completely achieved by a single application of abscisic acid. And cone shape is in fact an alternative to shearing, which removes 50% of the buds on the leader, as I just mentioned earlier. And here is a photo documentation from one of our experiments from Oregon, and you can see that a younger Christmas tree has a very long leader at the end of the tree, including several buds. And this is undesirable. This length is undesirable for a nice Christmas tree. And with the application of cone shape on the right photo, you can see that very nice short leader can be achieved with many buds on the leader. So that's the benefit of using this particular PGR, that in fact increases the value, increases the shape, increases the quality of the product. So these were the main uses of PGRs that I wanted to cover, and the main products that are in our turf and ornamental PGR portfolio. And as a summary at the end of the presentation, we can say that there are 5 classes of PGRs: the auxins, cytokinins, gibberellins, the growth inhibitors, and growth retardants. The growth inhibitors are abscisic acid and ethylene or ethifon, and the growth retardants are synthetic chemicals, synthetic gibberellic acid, biosynthesis inhibitors to reduce the growth rate of plants. These PGRs are used commercially to control plant growth and development and increase the value of ornamental crops. This is very important, that plant growth regulators increase the value or add value to to the ornamental crops and therefore increase the income of the growers. PGR effects depend on the species, the variety, the physiological growth stage of the plants, plus the dose and other factors such as the environment. So these are the main factors that affect the efficacy of the products. And the commercially available PGRs such as Cytoflor, ProGibb, and Cone Shape that we just reviewed are powerful tools to increase the value of ornamental plants. And the return on investments for PGR usage makes sense in most applications. So growers can achieve a higher return on investment by adding value to their ornamental crops. And with this, I would like to thank you for your attention today.
So we did get quite a few questions during the presentation about organic certification. So Joseph, can you tell us, are these certified to be organic?
Yeah, so basically not all of the plant growth regulators are certified for organic use or certified by OMRI, and the products that we covered today, ProGibb is OMRI certified, so it could be used in organic production. Cytoflor is not organically certified, and Cone Shape is being currently reviewed by OMRI. It's going to be registered hopefully early next year. So we really hope that it's going to get the organic certification.
And so if a PGR is used for as a substitution for chilling time, can you tell us about how that would affect the plant a little bit later on?
Yes, so basically we could use gibberellic acid, for instance, for chilling substitution. And what happens is that's just a trigger to replace the cold or the chilling requirement. Basically, it doesn't really impact the later growth or the development in later stages of the plant. It just serves as a trigger. So basically, once this trigger applied as either a chemical or a chilling requirement, the plant go into the regular growth and development stage.
And can you tell us a little bit about how plant growth regulators can counteract things like drought, heat, salinity, different environmental factors?
Yes, plant growth regulators are normally not registered for or not used for these general purposes to address like salinity or general environmental stresses. These plant growth regulators are used for specific purposes to specifically address growth and developmental issues, for instance, increasing the shoot growth, increasing the flower number, and things like that. Although what I have to mention is that there's no plant growth regulator or plant hormone registered for general stress tolerance improvement. But the product that, in fact, we talked lastly, that is a Cone Shape, its ingredient, the active ingredient is abscisic acid, which is a stress hormone. So in the future, there might be a product coming out that could be used for stress tolerance improvement. But at this moment, there are no products registered for this use.
Okay. Another question here, does the effect when you use it on perennial plants, does that have any long-term effect on the plant's growth, flowering, things like that? Or would it only affect the plant in the months in which the PGR is applied?
It normally affects the plant, in that time frame when it's applied, or it has an impact for weeks or maybe a month or so, because these plant growth regulators are used in very minuscule, very small amounts, and they are quickly metabolized by the plant. They have a great impact, they have a great efficacy at the time when they applied and shortly after, but they are quickly metabolized in the plant, and they have this short-lived impact on plant growth. So that's why it is important that if you don't see the desired effect, for instance, with cytokinins, with cytoflor, you have to reapply. You have to wait, I would say 10, 12 days is normally enough to see some sort of growth response. So they respond, the plants normally respond very quickly to these applications. So if you don't see the desired effect, you normally have to reapply.
And someone is actually asking if you can tell them what makes a plant have foliage but no bloom for 2 to 3 months. Is that a PGR issue? Is that something else that they might be dealing with?
So they don't have foliage, or they don't have
so they have the foliage, but they don't have any blooms for like 2 to 3 months.
Oh, after PGR application, or it's a general?
I think this is a PGR question.
Oh, yes. So if there are some PGRs that are registered to, in fact, reduce the flowering, and for instance, gibberellic acid in the vegetative stage, or of, for instance, azalea does this effect that, in fact, counteracts the flower formation when it's applied in the generatives, in the vegetative stage, or in the growth stage of the plant. So that could happen, that it reduces the flowers or the flower formation. And that, it really depends. The application of the timing of the plant growth regulator really depends on the desired effect, because as I mentioned earlier, depending on the timing in azalea, for instance, when they are in the dormant stage, when they are in the flower development stage, when gibberellic acid is applied as a trigger to substitute chilling requirement, it increases the flower formation. It enhances the flower development. And later, at a later stage, when the plants are in the vegetative stage, when they have shoot growth, growers normally don't want flowers to form. And that's why gibberellin at a different concentration, at a little bit lower concentration, at a different time, has in fact the entirely opposite effect. So that could happen.
Gotcha. And are there any effects on the root systems after you make a foliar application? Does that affect the root system at all?
They normally don't have a significant effect on root growth.
Another question here, how does alkalinity affect the use of PGRs, or does it at all?
We normally say that PGRs should be mixed in water that is close to neutral, close to 7, so 6, 7, or 8. pH is probably the best for these PGRs. But it really depends on the plant growth regulator. So these are normally listed on the labels that what pH they should be applied at. But in general, what I could say is that they should be applied with a water, or in an irrigation water, or a spray applications when the water pH is close to neutral, close to 7.
Tech question here, can you develop resistance from overusing the same product here?
No, not that I know of. We haven't seen any issues with that, because what happens if you apply it multiple times, you increase or enhance that effect. So if you apply, let's say, a gibberellic acid several times, or over apply it, you get an excessive elongation. So that's more like a toxic effect, a phytotoxicity that you don't really want to see. But there's no resistance buildup in the plants to plant growth regulators.
Okay. And let's see here. Can any of these products be used to break dormancy on seeds in particular?
Yes. For instance, gibberellic acid could be used to break dormancy, but I think they are not registered for that use. There are several research publications out there showing that there's an effect, but it's not registered for that particular use.
Okay, and actually speaking of registration, got a couple questions from our folks, or from our friends in Canada, if the products are registered in Canada, or if they will be, what does the timeline look like there?
Well, that's a really good question. I think you have to send us an email, and I have to forward this to our business manager, because they know this better than I do. I'm more of a technical person. I am not entirely sure about the registration situation in Canada.
So yeah, we'll look into that, and we'll follow up with some of the folks who were asking about that. Another question here about cytoflor. How is that product typically applied? Does that depend on the plant? And can you mix it with other products when you're doing, say, like a drench with a fertilizer?
Mm-hmm. Yes, it really depends on the desired effect and also the plant type as well. We normally apply it as a foliar spray, and the reason for that is because this plant growth regulator doesn't readily move within the plant. So if we want to have a nice branching effect, we recommend to apply it with the full coverage of the plant because it doesn't readily translocate. However, we've seen efficacy with drench applications, so it could be applied as a drench. It really depends on the operation or how is it practical to apply. For instance, in liners, maybe drenching would be more efficient. As far as mixability of the products, it really depends on the chemicals that that is mixed with. We normally do not recommend plant growth regulators to be mixed with other production inputs because they have a very specific timing, and the application time for other products like fungicides or insecticides might be different than the optimal application time for the PGRs, and they might interfere with the desired effect of the plant growth regulator.
Gotcha. Okay, we only have time for a few more questions, and then we're going to have to wrap it up here. So
okay.
Maybe we'll have a couple more. One of the last ones is this person doesn't seem to get a dependable frost early in their harvest to help with leaf drop. So can PGR application actually trigger leaf drop for harvest?
Yes. So there is one product out there. In fact, Valent Biosciences has a product, an abscisic acid product, which in fact a dormancy hormone as well. It's called proton plant growth regulators, and this is registered only in, I believe, apple trees at the moment for nursery uses, because what happens is sometimes there's not enough cold, not enough chilling, so the leaves are not falling off the tree. So what abscisic acid does is it in fact triggers the leaf drop, and it triggers it in a way that in fact increases the remobilization of nutrients from the leaf before they fall off. So this is very important, that the nutrients, particularly nitrogen, that is important, translocates back to the tree, and then the leaf falls off. So there's one product, it's called Proton, for apple nursery tree use, and maybe in the future this label will be extended for other trees as well.
Okay, and last question for you here today. If you are using a PGR and it adds branching, we have a couple questions about subsequent root growth. Does that lead to plant instability? Kind of what do people need to look out for there?
Sorry, could you repeat the question? I had some issues with that sound.
Yeah, so the question is, if a PGR is adding branching and it's not adding subsequent root growth, does that lead to plant instability, or is that something people need to be concerned about?
Normally, they shouldn't be concerned about this issue if they choose the right timing for the application. So we normally recommend if you want to have an advanced lateral growth or advanced lateral shooting, the plant should be ready for that. So there is an adequate plant growth, there's an adequate root development, and also a shoot development, so the plant could support the increased branching and increased canopy, increased density of shoots. So that's just important that if they don't really impact the root growth, what happens is we just have to wait with the application timing and just time it at the stage when we believe that the plants are ready to branch, and they would be they would be supported, by their root growth and their stem, in fact.
Okay, well, that's it. We're going to wrap it up. Thank you so much, Joseph, for your time putting
Thank you.
Presentation together and answering all these questions. So again, if there's anything that you missed, anything that you want to go over, a recording is going to be in your inbox in a couple of days, and we hope you will join us for the next one.
Thank you very much.
Bye, everybody.
Thank you.